Hello, everyone. Welcome to the monthly community call. I think this is the final one for this year. We're trying, as I mentioned in emails, there have been efforts to try to tie up loose ends and end the year on a strong note. But we still managed to get a few exciting things across the finish line, and we're keen to show you. I think I'll be going first to demonstrate some of the work around our Thema project, some of the motivations behind that, and how and the future that we see is opening up. So I'll share my screen. Okay, so Thema is our semantic theme project for documents, for HTML documents, primarily generated through our encoder project, but not necessarily limited to it. And these are CSS styles and selectors that target semantic attributes. So rather than targeting just divs and spans and things like that, we target things that have a bit more inherent meaning, such as articles or figures, as well as layering on additional microdata attributes that are part of the HTML spec. So you can see the project here and kind of get an overview. But to demonstrate what that looks like is, we have a simple theme viewer that Nokome built a bit ago. And so what you can see is that we have loaded several different types of content that you can open up. So we have a simple article that just has a list and paragraph and some code elements. Or you can see a full-blown R Markdown document converted to HTML and see what that looks like. But the power of the themes come when we switch between them and we're able to stylize these different elements in different ways without having to change the underlying content. So we can see what the eLife inspired theme looks like, or say the public library of sciences. But one of the problems that we noticed internally, as well as from many people working on CSS, is that these themes are created usually by different people who don't have much understanding of other themes and how their changes are going to affect the existing themes. So we wanted to add some testing process to make sure that we don't break anything as we grow out the themes next year, and as we bring on hopefully more people to work on the themes. And one of the ways that I had done this before was using visual regression testing. And what this process is you have a baseline reference image, or usually a screenshot of a document or an element, and then you have that saved somewhere. And as you work and you make changes, as the styles change, the paddings and the colors are modified, you take a new screenshot and you compare the two to see what the differences look like. So rather than explaining through words, I will show you what that looks like. So inside my Thema folder, and inside it, initially when you run the test, you generate some reference images. So you can see we have these 4 different articles. So we have the antibodies, the Drosophila article, the R Markdown, and the Firefox, the simple article. So if I show you what this looks like is it's just a full-length screenshot of the HTML document as it looks like with the current theme, the Stencila theme. And so if we go into my editor and I uncomment these changes, so we increase the body font size, we change the margins, and we change the color of the links, say, and we save this, rebuild the themes and rerun the tests, you'll see what that looks like in action. So we built the new themes, and then we are opening up the tests in Firefox, oh, that is, that's why. I forgot to uncomment my pre-made version. So you'll see that we open up the document again in Firefox. We rerun the tests, and we save the image. So if we see what happened is the initial failure broke the run through, but let's give it one more try. And so you see we got this error in our test saying a visual regression test failed, and it gives us a screenshot location to compare. So we see that in our themes test screenshot diff folder, we will see an image highlighting what the differences are between the two, the original styles as they were, and what my style changes down here, the increase of the font size, margins, and colors, how that affected it. So if I open this up, you will see that we get an overlay comparison of the original, which is underneath, and this the magenta colored, telling us what the differences are. So you can see that things are moved around, things are misaligned, and it probably is not what we want it to look like. And that allows us to easily spot the differences, go back and make changes and make sure that the only differences that we're seeing are the ones that were intentional and that we wanted to apply. So this this process that I outlined is what happens when you're testing locally. But of course, when you're working in a team and you're making contributions to the Thema project, people can't be expected to run it locally. And so what we're using is a new project or the combination of a few projects to help make the review process of these themes easier, as well as easier to kind of keep track of what the changes were and where the changes were introduced. So one of the projects that we're using is the WebDriver IO. So this is the project that allowed us to open up the Firefox browser or any other browser that supports this standard, navigate to the pages and take screenshots. And this is this connects to the Sauce Labs project, or Sauce Labs, which is a service that allows you to run virtual browsers on different virtual environments, to run different browsers across different platforms and different versions. And they have a very generous open source tier that they granted us. And so what that means is we can use WebDriver to connect to a Sauce Labs instance. And then this instance, I have a Windows 7 running Firefox 70, I believe. And you can see what the commands were to that WebDriver sent Sauce Labs, and what the logs that were generated, as well as a video playthrough of the pages opening up and being tested. So this is a really good way of debugging any errors and any issues that come up. As we can see that there was some kind of discrepancy here, and you can navigate through the full video playback and compare, see what happened exactly. And then lastly, the third project that we're using is Argos CI, which takes the screenshots that were generated, the ones on my local machine that are the reference images as well as local images. But Argos takes them from the continuous integration service, so you don't have to upload anything from your machine. these get automatically sent from Sauce Labs using Travis, and there Argus compares the images and gives us that similar type of comparison that we saw in using the magenta color. We can see if some things are misaligned or something's not quite right, and you get a very clear indicator in your GitHub pull request with a check mark or a cross if things don't look quite right. And so this is a initial kind of step that we took to help us develop these themes and make sure that we weren't introducing any unintentional style changes. But we're hoping that this will really make it approachable and easy to add themes and be very confident in that all the new themes are solid and they're not going to break anyone else's styles. So yeah, thank you. Let me know if anyone has any questions.
Yeah, that looks that's really cool, and I think it's going to be really useful. Just wondering if it takes into account, or if we can use it for cross-browser testing to see that things look the same between different browsers.
Definitely, yeah. So this you can compare that certain elements look, have this rough, threshold. Obviously, there are differences with how browsers render some details. Something like text anti-aliasing, some like inherent, I don't know, there's some minor differences between browsers, but we can test, we can have as large a suite as we want to take screenshots or compare elements, but the exciting thing is beyond Thema, WebDriver has capabilities to interact with different elements, and you can have cross-browser testing support using Sauce Labs to make sure that your click handlers are working as intended and all the functionality is there. And as you can see, I opened this page up to see to show all the different versions, resolutions, and platforms that Sauce Labs provides.
Cool. And I had another question about can you show or maybe just talk about the process for if there is a change to accept that and maybe make that the new canonical version?
Yeah, so I think, let me see if I'm logged in. So this one, so this PR doesn't have anything, since this is the first kind of pull request that Argus is seeing. So it assumes that what you have is what you want it to be. But I can show you what happens when you don't have when there are discrepancies. You see a what do you call it, like the orange sidebar here to indicate that this image is different, and you can either accept or reject it manually. So yeah, that's kind of one of the drawbacks, is that if there are discrepancies, you have to go in and manually verify them. But at least it's easier to know what you need to focus on, and it really narrows down, like the haystack that you need to go through.
Yeah, those are my questions. Cool.
Alex, I had a question just around that and the manual rejection. Will Argos send the committer an email that they've broken?
That's a good question. I don't know. I know that it will show a cross on the PR, and you can have that be a blocking, like a mandatory check.
Yeah. So it might be that the reviewer of the PR that's going through and accepting or rejecting. Yeah.
Yeah.
Great. Thanks.
Sure. Thank you. Yeah.
I'll go ahead now and share some of the stuff that I've been working on. So I'll just take a moment to share my screen Yeah, I think this is the right screen. So at last month's community call, I was demoing the work that we've been doing on Sparkler, and I'm going to today talk about a little project that's spun out of that. It's more of a developer-facing project that takes something that we developed in Sparkler that seemed to be more generally useful and makes it into a utility library, similar to the way that we set up a utility library called Logger for logging. So in Sparkler, this is the repo for Sparkler, and I just want to scroll down to the bottom where we've got this table of options. So Sparkler's got a lot of different options, configuration options, things like just whether you're in debug mode or not, the host that's going to listen to, the port, and so forth. And then it's got things like the session types, the total number of CPUs are allocated to each section, and so forth. So if I scroll down here, it's got a lot of options that we wanted to document so that other developers could easily pick this up and deploy Sparkler. And because it's got a lot of these different options, I developed an approach in Sparkler to try and make that less repetitive and more type safe. And so that's what's come out in this tool called Configa. So today I'm going to talk a little bit about that. This you can see is only about 9 days old, this repo, and it's in early development, but it's already proving to be useful. We've got a lot of other things to do, so we're not planning to spend a lot of time on this, but I thought I'd just share a little bit about the approach and get some feedback on that. So what Configa tries to do is give you a way of defining an application configuration in a dry, don't repeat yourself, and flexible and type safe manner. So I'll describe each of those in turn and how Configa tries to solve that issue. So the way that you approach application configuration, we're using Configa, is to define your configuration using TypeScript. So that comes to the type safety aspect of this tool. Where instead of configuring the application using like strings, as I'll show you in some other tools, CLI tools, or in, say, a schema object, you define it in terms of TypeScript. So we've got a class called config, and each property of that class is an option of our configuration. So we've got the first option here, A, in this example, can either be a Boolean or a string, and its default value is a string. We've got, each one's got some description, documentation, and the comment about it. And at the top level here, we've got a description with some placeholders where we can interpolate data from the package. So what this will do, as I'll show you later on, when we build this this configuration up into our application, it'll actually insert the version number from the package.json file and the description from there too. But you can also customize that to be whatever you want to have in your showing up in your help text. The other thing that Configa does is allow you to set constraints on your options. So in this submodule called define, we've got a bunch of validators that you can apply as decorators. So we're using the new decorator syntax that is available in experimental support in TypeScript. And you can see we've got minimum and maximum here. So this option B, that should be, I can't have the same option name, that's a typo. In option B, we've got a minimum and maximum values. And when we actually try and set values using Configa, if we're outside of that range, we'll get an error. And there are a bunch of different configuration options available, and different validation options available. And they're all based on JSON schema, because what Configa does is it takes this configuration that you've defined in TypeScript, passes it using TypeDoc, which is a documentation tool, extracts out the documentation comments and the type specifications, and generates a JSON schema for you. So if I go and show you the code here, what we've got is all the define. We've got all the keywords, validation keywords that are defined in JSON schema. So you can have an enumeration, value, that's number can be a multiple of, maximum and minimum, as I showed you earlier on, exclusive, maximum, etc. All the way going down to the minimum and maximum length of a string, the regex pattern that a string must match, number of items that are in an array, whether it should have unique items, whether it contains a certain item, so on. All the different aspects of JSON schema validation are available in these decorators in Configa. So once you've defined it, you generate your JSON schema using this tool, and then you import that schema into your TypeScript code. So you'll note we're doing two things. We're taking our original definition, the config, and we're taking the schema that we've generated. The config's used at compile time to make sure that the code you're writing is type safe, so that you're not trying to use configuration options that don't actually exist. And then the schema is actually used at runtime to validate the inputs that you might have at the command line or in a JSON file or an environment variables. It validates that those conform to that schema. So it's a separation of compile time and runtime validation. And so here, this is an example of actually using in my tool. I'm going to collect all the options, and they're going to be of type config, which I defined earlier. It's going to look potentially look in files called configure.json in this instance, but whatever my application name would be, I would put it there. And it's going to check that they're meeting that schema. And then it can do other things like print out some help usage based on those definitions. The other thing it does is generate some README documentation like I showed you before. And so here's an example where we're using Configa to actually document itself. So this table here is the actual configuration options in Configa. And it gives you a table with the description. It all came from that TypeScript, and the types came from the TypeScript and the default values. So I'm going to show you just quickly how, let me try and just change the screen a little bit here. So that's how we approach it in Configa. I just want to contrast that to how some of the other tools that are available for doing this sort of thing allow to configure options. And this is from our Doctor repo. And you can see here we've got, we're using Yargs, which is a really popular command line tool. And obviously that does a lot more than Configa does. But I just wanted to point out how options are defined there. And this is a common approach to use this DSL, domain-specific language that is part of JavaScript or TypeScript in this case, to define each option. So here we're going through and saying we've got this option from, and then there's option Stencila, and we describe it and so forth. But it's done in a way that's quite specific to that particular tool, whereas with Configa what we're doing is we're just using standard TypeScript type definitions and commenting standards to specify all this sort of stuff. That has the advantage too that we get the validation, and we're able to not just collect these options from the command line, but we're also able to collect them from configuration files and environment variables. So let me show you this in action. And the reason that I started working on this was because we're moving a bunch of those configuration options that we defined in Sparkler, and we're going to put them into Executor, which is our more general tool. And so just to show you this in action, I thought I'd show you how I'm using it in Executor. So in Executor, we've got a config.ts file where I define the options for Executor, such as whether we start certain servers. And this illustrates well, I think, just the different ways that we can define things like the configuration options for, say, WebSockets can be a Boolean or a string, and defaulting to false, which means that we won't by default start up a WebSocket server. If you put true in there, then it will just use a WebSocket address, the default one, but you can also specify when to override that. We've got here pairs, which is an array of strings, which defaults to this value, just to discover pairs on the local machine. And then we've got other ones around length of the queues, where we're unable to fulfill a request straight away. We put it onto a queue, and so there's some options there around queue length and checking interval and so forth. So having defined that, we can then use Configa to generate the schema, as I showed you before. So what that's doing is it's grabbing that configuration. I've got at the very top of that the description of its executor and the version number. So you can see that it's generated that, interpolating the number in, and creates the JSON schema that describes each of those options. So it's got the short description, and then the longer description in the comment, and then here where we've got a Boolean or a number, it's putting in an any of and so forth. So yeah, Configa generates that for you at development time. And then in my CLI tool, which I'll just open up here, the CLI tool is going to read that in. So let me find where that is. Just here. So here we're going and saying, collect the configuration options defined in that config from executor, for the application executor, and then we're reading it in, and then we're going to use those configuration options in various places in our application. And as I showed you before, it generates a README with a table, and that's what that table looks like. So then, just to finish up, I'll just quickly show you what that looks like. As I said, we've got these various options like queue length, and they're documented in the README, but we can also show them at the command line. So let's run this application that I just showed you and just get some help. And that shows a description and all the options, and there's the type of value and the default values. We can then go, and I think this will work if I just go WS, it will give us, this is still in development, but it'll give us more detailed information around that particular option. So let's do something else, which is just to reflect the configuration. So in this tool, the conf command just reflects the configuration. So this is a default configuration that's defined in that TypeScript class. But then we can start to override things. So let me set the queue length from the default of 1,000 to 0, and you can see the configuration option gets overridden. I can try and do something silly like setting the queue length to -1, and it gives me an invalid value warning error, and tells me that it should be greater than 0, or I can try and set queue length to foo, and it tells me it should be a number. So all this validation is coming from using AJV, the schema validator. So we get a lot of stuff from free taking this approach. And we can set these environment configuration options differently. So we can use environment variables. So I can set the queue length with an environment variable. We can also set it in configuration files as well. And just to finish off, I thought I'd show you, just demo how this can be used with the REPL that we've got in Executor. So a few months ago, Ben demoed using a command line tool, a REPL, what's a read, evaluate, print loop, to use Executor to execute bits of Python and JavaScript code. So I've repeated that here in this tool, so it's become part of Executor. And here we're using the pairs option that is defined up here in the README to say that I'm want to set up a pair which is going to be a Docker image that is going to get started up. So the command prompt starts with a bit of Python, and I can execute some Python code. There's a bit of a delay as it starts up that Docker image, but now I've got a Python session and I can execute Python code just like Ben showed a while back, but we can also skip to different languages. So I'm going to skip to JavaScript and do execute some JavaScript in that container. So yeah, that's just a little toy example or toy application of using Executor, but it's also quite useful for being able to debug it and setting different pairs, such as remote pairs, and checking that we can connect to them and execute things like this. Thanks.
That's great. It's really cool seeing all that come together, and I think that Configa is going to be useful for that. So unless, Alex, have you got any questions, or should I go on with?
Yeah, you can go on. Yeah.
Cool. So I haven't been working on, I don't have anything quite so interesting to demo, but as part of our support for some of the projects that we have in the pipeline, I've been working on exposing REST API for our hub. And this is to support some of our first-party applications, but as part of that, we'll have an API that that our users and third-party applications can take advantage of when it's ready. So I've just got a real small little demo just to show it off. So it's essentially just a basic REST API using JWT for authentication. So I'll just authenticate there, and it's simple. We just pass through the username and password. This is test credentials running on my machine, so don't try and hack me with my secure password there. So that that just gets posted through as JSON, and then we get our token back, JWT. And then, of course, I can just verify that that's okay. So we can post the token back to this verify URL, and we'll get a response with the same token back, and we can see that's okay, which is good. And then a really simple thing that we can then do is just fetch a list of projects. So I'm doing a post, doing a GET request to the projects list, and of course, it's just including that JWT in the authorization header, and just get back a list of projects as a response. And the next thing that that we're going to do, which is actually the last thing, this is a real quick demo, is just to fetch a manifest for our execution environment. So this ties back into what Nokome was just demonstrating with Sparkler and Executor. For a client to be able to connect to an execution host, it needs to know what host it should be using. And so we can specify specific hosts for different projects. So this ties back into being able to bring your own compute. So you can we can host compute for you in our hub, or you can provide your own, and we have the ability to provide a list of executors that you can use. So So that's just doing another get to get the list of, get the manifest of executors for this particular project. And you can see it gets back here a URL for an execution host, as well as a JWT, which contains information for authenticating to this particular host, and resource quotas and session limits and that kind of thing that can be used there. So this is only returning one, but in the future we could return multiple, and depending on the type of execution you want to do, we can go through and try connecting to different hosts for different types of work. So yeah, that's a really simple, short demonstration, but it's just something that we have in the pipeline for future work, and hopefully we'll expand on that and get more options for our users as well as us to be able to use.
Thanks, Ben. Yeah. So could you just clarify with that? So the JWT that you get initially, that identifies your user account, and so when you get that list of projects, it's only the ones that you have access to. Is that right?
That's right. Yeah. So yeah, the first JWT is used to authenticate you, and we have quite a complex permission system, so that your particular account might have, your particular user account might have access to projects that you own and projects that you just have read access to and that kind of thing. So this default view is just projects that you own. But of course we'll have the option to say, give me projects that I have access to, or projects in my accounts and that kind of thing. And you notice that when we got the JWT for the list of executors, that's a different one because it's a JWT that the executor needs to know about. So there's one for the hub for authenticating and a different one for the executor. But that's kind of transparent to the end user. You should just be able to take that manifest list and pass it to an executor client, and it knows how to process that and work with that.
Cool, thanks.
Yeah, thank you, Ben. Unless anyone has anything to add or any other questions, I guess we can wrap up.
Well, good. Yeah, I think, it's like a lot of these are sort of still foundational things that we're working on under the hood, but it's all, as Ben said, coming together, and things are, the parts of the jigsaw are coming together, so it's good to see.
Yeah. Well, thanks for the great demos, everyone. Anyone watching, thank you so much, and see you in the next year. Right?
Yep, see you next year.
Bye.
Bye.